Students, in this video, I'm going to show you how you can perform binary classification on tabular data using TensorFlow Keras library. Normally, TensorFlow Keras library is used for several tasks on unstructured data, such as text or images, but you can very much use it for tabular data as well. And that is what I'm going to show you in this video. I have already written a blog on this topic, which you can see here. You can go to pythonicly.com and you will see this blog here. And if you want to read instead of watching the video, you could just go there and read this blog. It contains the same information that I'm going to show you in this video. So let's start. The first step is to import and install the required libraries. Since I'm using Google Colab, I do not need to install anything. You could just use it by default. All these libraries will be installed by default. And the dataset for this article or this video, you can download it from here. So this is the dataset that we will be using. So just press Shift and Enter here. I have already downloaded the dataset and uploaded the dataset in Google Colab, as you can see here. So I will just create a new section in my Google Colab. I always create these sections because they are used. So you press Control and M here, Shift and Enter. Sorry, Control and M. I don't know why it's not creating a new section. Oh yeah. So when you press Control and M, this text will be processed as a markdown format. Next, we will read the CSV file using pandas.readCSV function here, and I will display the shape of this dataset as well as the first 10 rows. So I press Shift and Enter here again. You can see this is how our dataset looks like. It has many categorical columns as well as some numerical columns. You could see here capital gain, capital loss. And our task is to predict whether a person, so this is a record of a person, whether a person earns more than 50k, as you can see here, or he earns less than 50k, less than or equal to 50k. And we have to predict the values in the income column using the values in all the remaining columns. So these are our features and the income will be our output label. And as I said, this is a binary classification problem because we only have two possible outcomes in the output, whether a person earns more than 50k or he earns less than or equal to 50k. So the first step that we want to do here is let's see this dataset a bit. If you look at this dataset, you could see that many columns here, they contain question mark. So these are the missing values. So these records do not have any values for these columns. So you can see for row number 4, actually this is row number 5 because the indexes start from 0. So in the occupation column you have a question mark. So this is a missing value. Normally there are many ways to handle missing values, but the simplest one is to simply remove all those rows where you have a missing value. And we can do so with this script here. Basically it says that if this is our adult dataset, if any of the columns contain question mark, remove that row. So this basically says do not include that row. So we press Shift and Enter here. Now we have 45,000 records, more than 45,000. Initially we had 48,000. So we have removed around 3,500 rows, I think, yes. Next, we can see the distribution of label. So if you print the value counts on the income column and normalize it to true, you can see that around more than 75% of records are of those people which have income less than or equal to 50k, and around 24% people have income greater than 50k per year. Next, we will divide our dataset into features and labels. So X here is our feature, and our feature set will contain all the columns except the income column because this is our label, and the label set will contain the income column. So again I press Shift and Enter here to run this cell. One problem here that we can see is that our dataset contains many categorical columns. A categorical column is a column which contains categorical values instead of numerical values. But machine learning algorithms, they work with numbers only. So we have to convert these categorical columns into numerical columns. Let's first see. So you can see the categorical columns here. For example, race here, it contains many categories. Work class here, it contains many categories such as a private employee, a local government employee, self-employed, etc. So this script will give you all the categorical columns in your dataset. So these are the categorical columns in our dataset. So one way to convert these categorical columns into numerical columns is by using a technique called one-hot encoding. So let's see this code will print the value count of different categories in the work class column. So we are just using this column as an example to explain you one-hot encoding. So you can see that this work class column has 7 unique values, 1, 2, 3, 4, 5, 6, 7. So in one-hot encoding, what you do is you replace the original columns. So work class column will be removed and 6 new columns will be created. So the data for the private column will not be created here, or like one of these columns will not be included in the final list of newly created columns. So you have this column work class, this will be removed and 6 more columns will be added. One of these columns will be removed, and in those 6 columns what will happen is 0 and 1 will be added based on the values in this original work class column. So let me explain this with the help of an example. Let me show you how you can convert categorical data in your pandas data frame to one-hot encoded vectors or columns. So this script basically does that. So here we are using drop first is equal to true because actually we do not need 7 new columns, 6 columns will be enough, and you will see why. So press shift and enter here. So now our data set contains 96 columns, which originally contained around 15 columns. So because in place of a single categorical columns, multiple new one-hot encoded columns have been created. And those one-hot encoded columns will have values 0 and 1. So let me explain with an example. Let's see the data of all those work class columns. So this work class column has been removed, and in place of that 6 new columns will be created, and each column name will start with the string work class. So work class local, because we have local government here, work class private because we had a private here. So 6 new columns will be created. Let's print the data for those 6 columns that start with the string work class. So here this basically filters all those data columns, pandas columns that start with the string work class, and then it displays the top 10 rows for those columns. So you can see here. So these are the new columns that are created in place of the original work class column, and you can see that these columns, they contain one-hot encoded vectors. So one-hot means 0 or 1. So how it works? First of all, you can see that here you do not have all these 7 columns, instead you have 6 columns. I think the column which is missing here is without private, local government, self-employed, state government, federal government. So I think the column for this federal government category is missing. But what happens is, if the values in all these columns are 0, we consider that this record belongs to an employee which is from federal government, because if all these columns are 0, means this employee doesn't fall in any of these categories. That means he will be a federal employee. So if you go and up and see there, so in the work class column in the first and second row you had private category of employment, and in the new one hot encoded vector you can see that in the first and second row the work class private column has 1 and the remaining columns has 0. So again, if we go up in the third row, the work class was local government, and in the new one hot encoded vector you can see that in work class local government column you have 1. So the original column with categorical values is removed, and in place of that multiple new columns have created which contain 0 and 1 value. So this is how we convert our dataset from categorical to numerical values. And we will do the same for our label, because our label is also, if you look at it here, it is in the form of categorical value, string values. Basically we want to convert it into numeric values, so we can use this code. So yeah, so if the income is greater than 50%, 50,000, you will see a 1 in the record, else you will have a 0. Normally whenever you do a binary classification problem, you should have only one column in the output, and that column should ideally contain 0 and 1. Let's now again print the shapes of our features and label. So we have 96 features and one output label, which can be 0 and 1. Next we will divide our dataset into training and test set. This script does that. So we will divide our dataset into 80% training set and 20% test set. Finally, we will scale our dataset. It helps improve it helps fasten the training, so it expedites the training process, because multiple columns, they can have very different values. By scaling them in a certain range, you can actually increase the speed of training. So here I'm using minmax scaler from sklearn library. You can use any other scaler if you want. So now we are ready to create a Keras model on our dataset, because we have everything set up. So I will create a new section in my Google Colab notebook here. Sorry, yeah, I don't know why it is very slow today. So let me execute. I don't know why it's behaving like that. Anyways, we can leave it like this. So this will be our Keras model. Let me again try it once more. Yes, now it works. I don't know what's happening with the Google Colab notebook. So this is our model. Basically it has an input layer, 3 dense layers, and an output layer. So I have used Keras functional API to create this model, and the input shape will be the number of features in our feature set, which you can get using this code. Then we have 3 dense layers. The first layer contains 128 nodes, the second 164, and the third 132. And finally we have an output layer. Always remember that whenever you are doing a binary classification in TensorFlow Keras, you should always use a sigmoid activation function in the output, and the number of nodes in the output will always be 1 for a binary classification problems. Sometimes they also use 2 outputs and use a different loss function, such as categorical cross entropy, but I am not a very big fan of that approach. So you have a binary classification problem, just use 1 node in the output, and the label should contain 0 and 1, and the activation function should be sigmoid. The loss function used normally for binary classification problem is binary cross entropy loss, and this method will return us this model. So I press shift and enter. We can print this summary of our model using this script. So basically we're calling this method that we just created, get model, and we are printing the summary of our model. You can see we have an input layer, we have 3 dense layers, these are the hidden layers, and 1 output layer with 1 neuron or 1 node. In the same way, you can plot the architecture of your model. So you press shift and enter, and here you can see how we can plot the architecture. So we have 96 features. We pass them to 128 nodes in the first hidden layer, then 64 nodes, then 32 nodes, and finally 1 output node, which is our prediction. Next, we can train and evaluate our model. So that is simple. We can use the model.fit method and pass it our training features and labels. The batch size I am using is 256. That means 256 records will be processed in one go, and after processing 256 records, the model will update its features. And I will train the model for 100 epochs. You can actually increase or decrease these epochs. And also 20% of the data from my training set I am using to evaluate the model after every epoch. So basically this script will divide the training set into 80 and 20%. The model will be trained on 80% for every epoch, and after every epoch it will be evaluated on the 20% validation set from the training set. So I press shift and enter, and you will see that model will start actually running. You can see here. So after 100 epoch, I achieved a validation accuracy of 84.16%. But it seems that let me first print the loss and accuracy plots. So this script basically does that. So you can see that our accuracy improved probably until 30 epochs, and similarly the loss decreased till 30 epochs, and after that it was not decreasing much. So we can probably train our model only for 30 epochs to reduce overfitting. Overfitting happens when your training loss is decreasing but your validation loss is not decreasing, or it is actually increasing. So again here I will run my model for 30 epochs. So you can see after 30 epochs we are getting 84.26, which is better than actually 84.16 that we got after 100 epochs before. So the next step is to, this is important. So to make predictions on your test data, you can use this script here and press shift and enter. You can see that our predictions here, they are in the form of probabilities between 0 and 1, and this is because we used a sigmoid function in our output layer. The sigmoid function, it squashes values between 0 and 1, basically outputs probabilities. So but if you look at our training data, our labels, they are binary, they are 0 and 1. So one way to convert your outputs from probabilities to 0 and 1 is by using a threshold. So here we use a threshold of 0.5, and we say that if these values, they are greater than this threshold 0.5, return 1, else return zeros. So if I execute shift and enter here, so now you can see, so since all these values, they are less than 0.5, this is why you are seeing zeros here. By the way, these are not all the values, this is just a snapshot of the output. Finally, you can compare your predicted values with the actual test labels using this script. Here I am using accuracy score method from the sklearn library. So I press shift and enter here, and you can see our model achieves an accuracy of 85.28% on the test set as well. So this is how you could do binary classification on tabular data with TensorFlow Keras. The main points here that you should always remember are that you have to convert your categorical columns to numerical columns, and one way to do that is one-hot encoding. Another important point is that if you go here, your output layer should have one node which should match your label, because your label set, your labels, they should also have one column, and each value should be 0 and 1. And matching that, your output layer should only have one node with a sigmoid activation function, and the loss function that you will use will be binary cross entropy for binary classification. And finally, when you will make predictions, you will get values in the form of probabilities that you have to convert, here you can see, to binary values, so that you can compare your actual labels with the predicted labels. That is that you can do using this script. So that's all for binary classification with TensorFlow Keras. If you like this video, subscribe to my channel and leave any feedback that you might have. Thank you for watching.